Attendees are in listen-only mode.
Well, good morning, everybody, and welcome to today's webinar, Sustainable Innovation. My name is Rob Romanowski, and I am the Director of Operations for 3HTI and 3DS Man. So those of you in our audience are probably a little more familiar with 3HTI and as being a customer of ours, but also we had started another sister company called 3DS Man. And the purpose of 3DS Man is to be able to fit solutions to our customers in areas of manufacturing so that we can provide a full service through and through, all the way from concept and design all the way through to end of life cycle and retirement of the product. So we are very excited to be a Dassault Systems partner. And we're also very excited to be providing you with this webinar today to examine the analysis software known as Simulia, formerly known as Abacus, to get a little closer look at this today. So a couple of things before we get started. Everyone's going to be on mute during the webinar, and we are going to have a question and answer session at the end of the presentation and demonstration of Simulia. However, if you have any questions during that time or before the Q&A session, feel free to type them in the questions box in your dashboard of GoToWebinar. And if we can answer them during the webinar, we will. If we're kind of moving along, we will definitely answer them during the end of the Q&A session. So I think together the total projected time with question and answer should be a little less than an hour. All right. So a little bit about 3DS Man. So basically, ultimately, what we want to do as a company, as I mentioned before, we want to be able to provide solutions in all phases of manufacturing. But ultimately, it's to help people live better lives. And that may sound corny, but actually, it's the truth. Because if you're a customer of ours and we're solving your problem and we care about your problem, you're able to get your job done a lot more effectively. You can reduce costs, you can reduce time, all these things that are super important to the company. But what's really important to you personally is probably just being able to be happier at work, being able to get home on a little earlier, spend more time with your family. Those are the more important things in life. So that's really ultimately what our focus is to help people not only be more innovative, but to lead better lives as well. So these are the product offerings that we have for 3DS Man. We have within the Dassault suite, we sell CATIA. We provide solutions for Simulia, which we're going to learn more about today. Innovia for PLM, as well as Exelead OnePart for parts management. We are also a reseller for Mentor Graphics, and we were actually named the Gold Partner of the Year for North America earlier this year for Mentor Graphics, which was pretty exciting. We sell a list of 3D printers and 3D scanners, including a carbon fiber 3D printer from Markforged, as well as 3D scanners. We also sell machining solutions from companies like Multi-DNC and Spring Technologies, as well as rendering software from Keyshot and a configurator from a company called Controls Pro Studio. So that is it concerning the breadth of solutions that we're able to provide our customers. So the key to driving real value from any technology lies in process improvement. So by employing various services such as contract staffing, employee education, consulting, training, we help our clients achieve a much more significant return on their technology investment. Here's a list of some of our customers, which if you see some of these names, it's kind of like the who's who within their industry. And I guess the point is from this slide, because we deal with companies of all different sizes, and no matter what, I guess the purpose of this is to just show that they're in a lot of different industries. So one of the things that makes us successful is being able to fall in love with somebody's problem. and solve the problem, not basically being pigeonholed into one specific niche. But the people that we have at 3DS Man are super talented, and we're able to solve problems with many different companies. And we've seen a lot of different situations and a lot of different issues within our partners, and it just those challenges have made us a much more effective partner with these companies as well as the smaller companies that we do business with. So it doesn't really matter the size of your organization. I guess what matters is that we're looking to solve your problem. We're not trying to sell software. We're not trying to push a solution. We're trying to figure out how to solve your problem, what the best way is to solve it. So with that, I am now going to pass everything over to Dipesh Shah. Dipesh has been with Dassault for 4 years and is an expert and an enthusiast when it comes to all things in analysis solutions. So with that, Dipesh, what I'm going to do is give you control.
Okay.
And
thank you, Rob.
You can take away the demo and tell everybody what you're going to talk about in the show.
Sure, definitely.
Thank you.
So can you see my screen?
I do see your screen.
Okay. So thank you, Rob, for the introduction, and welcome everyone. So I'm going to talk about Abacus and Power Portfolio. So the title kind of like, it says realistic simulation made easy, and that is what at Simulia. So until now, it was Abacus, and then we just kind of like, put other products into the umbrella. So there is 4 different products within one umbrella, and I'm going to talk about all into the specifics. So without further ado, I'm going to be getting into the agenda for today. So first, I'm going to talk about the Power of Portfolio. So what I have in the plate is there is one example for the stent, and then I'm going to use Abacus, iSight, Tosca, and FESafe, and then kind of find the complete realistic solution into it, and then right into the Abacus capabilities, what Abacus can do. So if you just want to find out the static stress, that can be done, or if you want to do the multiphysics simulation, that can also be achieved with Abacus. So I'll go through the examples and industries we serve as a Simulia, and then taking everything in between. Then Rob mentioned about the customer base being into the Pro-E. So I do have a great video showing the Pro-E associative interface where you can kind of on the fly bring in the part into Abacus and run the simulation, so that way you don't have to bring in as a dump solid via STEP or IGS into Abacus and lose all the parameters into it. So there is a great demo video into it. And then I'm going to talk a little bit about the Power of Portfolio. So Abacus is the kind of like a very well-known product into it, but the Tosca, FESafe, and iSight is a complementary tool to get you all the realistic simulation into it. And then in the end, I'm going to show you the Abacus interface, creating a very simple model from scratch, and then run the cantilever beam demo. So that way you can at least get a feel of it, not the touch because you still don't have the software, but at least get a feel of it, how the model can be made, and then how the loads and boundary conditions can be applied and simulated, and then finally post-processing the results. So I'll go through the pre-processing, solving, and the post-processing aspect of Abacus within one window, and we'll talk about that. So now I'm going to get into the Abacus. So as you may be aware, so you might have heard the name Abacus. So it's our flagship product, and it can help you solve all the problems you have using static, linear, nonlinear contact, or getting into the multiphysics of it. So all sorts of problems can be solved using Abacus. But now we have complementary tools within Simulia. So the other tool, which is the FESafe, it is the technical leader into the fatigue simulation or the durability analysis for the finite element simulation, and then getting into the process automation and design exploration. So there is a tool named iSight. which can do wonders, and that can be used into your parametric approach, and you can go ahead and build the models with like thousands of variations into it and come up with the best solution. And we'll talk a whole lot about each tool in particular and how things work out. And the last but not the least is the Tosca, which is used for the structural and fluid optimization. So you might be wondering why there are two tools for the optimization or design exploration. So one is the parametric tool where you put the parameters into it. So you go ahead and I want to change the length, or I want to change the thickness, or I want to change the width. So that is the parameters, you play with it. And the second one is the non-parametric, where you just can imagine a stone and then kind of carving to the statue into it. So that is where Tosca comes into the play. So you start with the landscape and it will give you the final product into it. So that is what Simulia does, and that is what the power of portfolio, so which can be Abaqus, EFISAFE, EyeSight, and Tosca. As you can see, it can all be integrated within one tool, and with the power of portfolio and extended tokens, all those tools, if you get the right licensing tool, that can be available for you to continue further with one versus another analysis into it. So now jump right into the example of it. So as you can see, we are talking into the cardiovascular disease or the stent analysis into it. So this workflow pretty much demonstrates into the Abaqus analysis. So that's first and foremost kind of a requirement. So we'll start with the Abaqus, and then we'll get into the EyeSight aspect of it, and I'll go into the next coming slides, and I'll show you the workflow, how things work out with Abaqus. And then once we're done with the parametric optimization using EyeSight, then we can go ahead and perform the fatigue life. So this all can be done at any phase of the analysis. So it doesn't have to be a particular phase, but you need to have stress results to get the durability or fatigue cycle into it, or strain results, depending on what base you're performing. And then eventually running into the non-parametric design optimization, which can be done using Tosca. So the reason I wanted to show this example, that where you can kind of visualize how the process works into the power of portfolio, and eventually all these components are done on its own. So we want to make sure all of these components, if you put it together or combine them together, they work for the best solution. And that's where reliability analysis can be performed using EyeSight for the different mediums into it. So now moving into the aspect or kind of workflow. So those was that the previous one was the high-level overview into it, and now I'm going to jump right into the workflow aspect of it. So first one is the crimping and insertion. So we need to crimp the strand to kind of compress it so we can put it into the artery, and then eventually put the blood flow or blood vessel flow into the cylindrical aspect and kind of run the insertion of the stent into the artery. So crimping and insertion is done using Abaqus. Then balloon expansion and attachment is also done using Abaqus, and then loading is being done. So now once we have run the Abaqus analysis, then we know, or we at least know, where the issues are or what are the peak stresses or strains into my model, which is kind of reducing the life cycle of my stent. And that is where fatigue or the durability analysis using EFISAFE comes into play. And this is being done with the stress strain based curved. And then you can also do the low cycle and high cycle fatigue. And I do have a great example for the handle into the EFISAFE analysis. So this is what we've done so far. So we ran the Abaqus simulation for the for the stent analysis, and eventually get into the life cycle of that particular problem. And now we are taking into the next level where we are using the parametric optimization tool EyeSight. So where these are the parameters. So if we take into account, so there is a length of the stent, then there is a thickness of the stent, and then there is a radius of the stent. So all these parameters can be taken into account for the stent simulation using EyeSight. And the best part about EyeSight it's a disparate solution. So it's not only like, you have to use Abaqus or you have to use Tosca or you have to use FESafe into it as a process flow component. But that can be simple Excel component, or you can also put in calculator component if you want to calculate particular variable into the analysis. So iSight does help or does control it can use any sort of process flow into the analysis. So first one, the model is created using SolidWorks. So that is where the stent parameters can be changed into it. Then pre-processing of the stent model. So that's the same flow or the component into it, and eventually run the Abaqus analysis. So this all can be done automatically, and in a ways you just have to prepare with the right workflow into the system, and that way it will do all the work automatically for you and eventually find out the desired results. So now putting all the parameters, this is where my best solution or this is where my best solution comes into the play. So that's where design sweet spot. So iSight gets you the results which you're looking for without running 100 or 200 iterations one at a time where you have to change the parameter. This saves a whole lot of time and trouble for you, but this can be like, human error can be involved into it as well. So iSight does the wonders. And so far I talked into the Abaqus simulation, then taking into the FESafe for the durability analysis, and then we also used iSight taking into the parameters, and then eventually, last but not the least, I'm going to be using Tosca for the shape optimization. So I've already got the desired or the optimized solution, but now I'm like, I can still get something better into it. So now I'm doing the shape optimization. So shape optimization can be done, and we can also put one would ask the question. It's like, if I go ahead and do the Tosca, that may give me free flow format of it, and that can be null and void because none of the parameters are meeting the requirements, and that is where all the manufacturing constraints you can put it into the design process, where you can say I want my minimum thickness to be 2 millimeter, or I want my minimum radius to be particular millimeter into it. So you can put all those criteria into the Tosca, even though it's a non-parametric optimization, but you can put the manufacturing or the design constraints into the analysis. So now the final solution, so this is what my baseline simulation, that was just after the Abaqus simulation into it. And then eventually I was like, I want to take it to the next level. I want to do the FESafe for the durability and fatigue analysis, and then eventually I want to do the optimization, which is based on iSight changing the parameters. But I was still not satisfied at that point, even though I got about 8% improvement. And then I went into the shape optimization. That is where I got about 6% more improvement. So eventually, my life cycle became 14% better by combining all the available tools within the umbrella of Simulia by using power of portfolio. So this was a very high overview into showing you the example where all we can relate into it, like I went into the Abaqus component, then I went into the iSight component, then I went into the FESafe component, eventually I went back to Tosca component, and now I can go back into the reliability analysis using iSight and making sure, because all these components are doing the design iterations on its own, but now I want to put the bigger picture into one umbrella, and that's when I can go ahead and do the reliability analysis, where manufacturing constraints or tolerances or parameters, all those sorts of things can be taken into account. And now I'm going to jump right into the Abaqus capabilities. So this is the big chunk of this webinar, just showing you the capability of Abaqus software and what it can do into it. So what is the realistic simulation? Because that was the title for my webinar. So realistic simulation is nothing but getting into the lifeline example into it. So right now, as you can see, this is the physical test done into the test lab. And this is the model created within Abaqus with lifelike simulation into it. So you can see this is the B pillar for the automobile, and that's where we're getting the lifelike example. And it's just because the tools have sophisticated so much over the years with the requirements and needs and kind of like value added into it. Now we can create all the materials, we can create the tissue material, and I'm going to talk a little bit about it. And then second example is for the side impact using the pole analysis. So you can see the model for the BMW, and then the real car and the indentation and all the all the crash analysis into it. It's kind of real into the simulation the way you'd see into it. So realistic simulation is basically physically realistic and lifelike in every way. And I'm going to take it to the next level where, why do we do that? So to reduce the physical testing and save time and money. How do we save time and money? Money is the main aspect. So where we don't have to create prototype for each design level into it. If we got the confidence into the product, then we can kind of avoid up to the final product and then go ahead and do the final product prototype and then eventually get the virtual validation into it. So that is how we save the money. So that's the side impact into the dummy. And this is a great example for the Mechanical Design and Analysis Corporation out of Japan. That's where the simple sheet metal buckling and kind of crash or the impactor analysis of the soda can into it. So to reduce the physical testing, save time and money, and improve the quality, because we can always go back and change like material properties and get the desired results, and then eventually save time and money into it. And now it's like if we have the robust nonlinear simulation tool, will we be able to stop making assumptions? The assumptions, we all have come across that. So we are like, I'm going to fix this part and maybe thin it rather than fix it into it. And then all sorts of assumptions is being rolled into the simulation aspect and then perform realistic simulation. So if we do have the nonlinear, so this is a great example using Abaqus for the Jenga. So we all have played this game once in a lifetime. So great contact functionality that is being done in Abaqus. Then this is another great example of wipe dispensing. So that is where the edge-to-edge contact and all the capabilities which is available within Abaqus offering that can be modeled into the lifelike example. And then so this is Velcro or the virtual crack propagation. So joining techniques to simulation, adhesive and delamination. So this is also can be performed within Abaqus. So this all examples, it's kind of like, advanced using explicit and standard. But there may not be need to perform this, but the reason to show it, it can do anything you want to achieve because it has all the capabilities of running the simulation. So here is a duck boat that is for the multiphysics simulation. So first on the road and then into the water. So that can be achieved within Abaqus. So then Beating Heart, the Living Heart project, so if you're really interested into it, Simulia has invested heavily into this particular cause, and that is being used by doctors as well. So it's the Living Heart. So there are a bunch of YouTube videos. So just do Living Heart, Abaqus, and you'll find all the related material into it. Then the geostatic or geothermal simulation into the earthquake analysis. And here is a great example of the smooth particle hydrodynamics using Abaqus, where you can do the multiphysics into it, housed with the fluid. And here is a simple explicit analysis for the ratchet. So if I want to find out the plastic strain into the ratchet and gear mechanism, that can be done as well. So these are just some examples, and in a ways that will help you into the moving forward with it. And then, as I mentioned, so you don't have to start with the expert level where you just do the fluid structure interaction into it or the delamination. You can start with a simple model, and then kind of depending on the need, you can eventually move into the desired solution. That is what we all want to achieve at the end of the day. As Rob mentioned, spend less time and then kind of get better results and spend more time with family. So these are the industries, just to name a few. So we are everywhere. So consumer packaged goods, Procter & Gamble is using Abacus heavily. Automotive and transportation, so GM, Chrysler, Ford, Toyota, just to name a few. Industrial equipment, we're at John Deere, Caterpillar, Case, New Holland, everywhere. High tech, Apple, Google, Amazon. Life sciences, Boston Scientific, and then all the other companies. And our aerospace defense go into the Boeing, architecture, construction, then energy. We are huge into the oil and gas industry down into Houston, Texas, and Dallas or Texas area. And now I'm going to walk you through, like, what is the offering within Abacus. So those were just the simple examples. But now, particularly, how Abacus or what can be done. The good part about Abacus, once you got Abacus licensing, all of this available tools, standard, explicit, and CFD, it will be available to you. The only thing will not be available can be like, if you want to run the scalable solution, then you may need to get more tokens, and I think that can be a question for Monica, Rob, or Gary, So Abacus Standard is the family of mostly nonlinear engineering capabilities, and it's designed for the production use, and that's where it can come in handy. In mathematical basis or finite differences method being used into the Abacus. In Abacus CAE is the tool I'm going to be showing it to you at the end of the webinar, which is basically complete Abacus environment. So what is complete Abacus environment? So you can do pre-processing, you can do solver, and you can do post-processing. That all can be done within one GUI. So that way you don't have to live it. And then it can be kind of performed all sorts of analysis. And Abacus is very well known for handling millions of degrees of freedom. And that is where it comes into the play. And then scalable solutions. So whoever is using Abacus, they are very happy with, like, let's say if I use 2 CPUs or if I use 16 EAP CPUs, the time kind of drastically goes down. And after a certain number of CPUs, the scalability is not that of a great, but that's kind of like going into the higher number of it. But it's kind of very exponential into it. So whatever model was solved using 22,000 seconds or 22,000 minutes into it, that can be solved under 5 times. So we got about 4 times the improvement into the runtime, and then reliable and accurate, because given all the materials and kinds of library into it, an extensive material model, so you can model the metals, rubbers, and composites, and you can also do the soils and rocks. You can also do the damage and failure modeling into the analysis. So all sorts of material modeling can be done within Abacus. So that's kind of like, helping you into the way to customize your solution. And then, as I mentioned, so there are 3 different modules or 3 different ways Abacus solves the problem. So Abacus Standard, it's based on your implicit solutions techniques. So it can be linear or nonlinear behavior. And then if you have an explicit time integration, where high deformation into this very short period of a time, where you can do think about the crash simulation, or you can think about the blow molding. So that all can be achieved within Abacus explicit code, and it does use the explicit time integration. And then Contact is kind of like, biggest asset for the Abacus simulation, where you can go ahead and do the fluid structure interaction, or that can be done onto the explicit. So here you can see a great tube crush analysis, where this is the real test, and that's the Abacus simulation. So you can see how lifelike it is, as long as you have the right material properties and right behavior into the model. That can all be achieved with Abacus into it. And now, kind of like, as I mentioned, you all are interested in looking into the associative interface. So I'm going to be showing you the video and demo which can help you. So here is my Pro Engineer, and that does the same thing with Creo as well. And that is my Abacus GUI. And I'm going to play the video and also talk about it. So first thing, you need to go ahead and create kind of a connection within to Abacus window where you can go ahead and I want to assign the port. So now you're just simply creating kind of an association or connection between two different GUIs. And the best part about ProE into it, so you can bring it automatically and you can also bring it into the manual way as well. So now within Abacus you can open straight up into CAE, or you can write the Elysium assembly file or EAF file, and that can be brought into Abacus as a manual approach. But I'm going to show you the automatic ways into it. So now exporting it to Abacus. So what I want to export is everything, solids and surfaces and everything. So now I'm just making my model ready, and then I'm just getting ProE model ready into bringing into Abacus, and I'll go ahead and open into CAE. So you can say now the whole model can be brought into Abacus interface, and that's what it's bringing into it. Bingo. So now we have list of parts and instances is summarized into Abacus CAE. So whatever way I had my parts named into it, those are the same ways it can be brought into it. And the one thing you want to do is view manipulation, because you're used to work in ProE and now you're working in Abacus. So mouse controls for the zoom, rotate, and pan, that can same be done into it. So now whatever changes you make into ProE, those can be enrolled into Abacus. The only thing, every time you make a change, you need to go ahead and open in Abacus CAE, so that way that can be kind of brought into Abacus. And now I'm going to do some of the operations within Abacus CAE, and then we'll see like how it's retained even though you make changes going back into ProE and bringing back into the analysis. So now, as I mentioned, like all the parts and components kind of follows the profile from the ProE, and now I'm creating the main purpose of bringing into Abacus. I want to create a finite element model and run the simulation. So I created a pressure loading onto the side face, and then I'm going to create sets and surfaces for easiness of output or easiness of applying loads or boundary conditions. So I applied the pressure, and then I'm going to create some of the sets within the assembly. So that set can be later used for loads, boundary conditions, outputs, any of the requirements into it. So I just want to show you everything you created within Abacus that will all be retained even though you made some changes into ProE. So now I'm going to make change into the backhoe or the bucket, and I'm going to be there is a suppressed feature into it, and I changed the dimensions of that as well. So I had a dimension of 250, I changed it to 200. So now bucket is becoming smaller into it. And now I'm going to suppress one of the whole feature, which I had a taken out. So I'm going to be suppressing that, so bring it back into Abacus CAE, and that all will be implemented. So you can see I made two changes, made the bucket smaller, and then put a hole into it. So opening that back into Abacus CAE does the wonders. So whatever changes I made into ProE, because I was working with the automatic associative interface, then it worked into the way. So the pressure was applied earlier, the sets were created earlier, all those has been retained even though I made changes into the model. So that is how ProE associative interface works. And not only ProE, but if you are a SolidWorks user or if you are a CATIA user, there are associative interfaces available which can be used for your own benefits into it. So I've talked about Power Up portfolio, I talked about Abacus capabilities, and now I'm going to be, then I talked about the associative interface, and now I'm going to be talking into the Power Up portfolio, each module on a very high level overview. And then if you need any questions, or if you have any questions, you can always come back to them, and then eventually we can help you solve your problems. So Tosca optimization module. So Tosca optimization is a suite of products within the module. So there are multiple modules into it. So the first module within Tosca, it's called the topology module. So topology does help you get rid of the mass or the weight from the model and still maintain the sets. So eventually you make the part lighter by 20% of the initial weight or 20% or 30% of it and still maintain the stiffness. So what it does, it kind of comes with the landscape. So landscape may not be a right way to do it. So you can always put the symmetric constraints into it and eventually come up with the manufacturable part, which can be lighter into it. So it's an optimization module where this can be implemented into the early production phases. Then the second phase is the sizing. So sizing is mainly used for the sheet metal structure, where you have a sheet metal thicknesses, and here is a great example of a whole body in white or the car model where you have 500 different sections of thicknesses, and you can go ahead and just run the simulation and say about 20% and still maintain the stiffness into it. And this can be done for the eigenmodes, eigenfrequencies, and all sorts of criteria into it. And the third one is the shape module or task shape module. So this module basically comes into the later phase of design where you have some hotspots or high stresses into the end of the analysis. So you can go ahead. So here the main thing will be, your main goal will be not saving mass or weight, but getting rid of high stresses or hotspots into the part. So that is where shape module comes into the place. So it does reduce the local stresses and increases the durability. And shape can be enrolled together with FESafe for fatigue simulation, and that can do the wonders, or it can help you get the desired solution. And then there is a bead module or task structure bead. So what it does increase the stiffness of the sheet metal structures, or does increase the eigenfrequencies. And the last but not least is the fluid topology. So that can help you with the channel flow to reduce the pressure drop or fluid flow into the analysis of it. So how it works, so you started with the CAD geometry, but then you come up with the design space, because this is, as I mentioned earlier, into it. So you're basically sculpting a part off of your volume, which can be the maximum volume you can use into it. And eventually we came up with the landscape of it, and then bring it into the geometry extraction. And sometimes the rib up here that may not be manufacturable, so you may need to go ahead into the manufacturing feasible simulation, where you can put the tolerances or put the stamping or casting restrictions into it, and eventually come up with the desired solution into it. So this was the TSCA module, and now I'm going to get into the FESafe. Right? So FESafe is why do we use it? So we do have to recognize the residual stresses, right? So courtesy of the Hyundai motor. So here is kind of the bracket into the analysis, and then the bolt loading is applied. So there is kind of a low level fatigue loading, which can be done into the linear aspect. You can also do the high level or low cycle or the high cycle fatigue loading into it. But whenever we do have some residual stresses rolled into the part, then going into the one aspect where kind of repetitive similar loading may not get you to the desired result, because the plastic strain is kind of not taken into account, and that is where you may come up with the nonlinear or the plastic model into the analysis to get the accurate results. So when we do the low level fatigue loading, then we know this is where kind of high stresses or high strains occur into the analysis, and that's where the failure is going to be happening. So whatever we predicted, we got the results out of it using the low cycle loading. And then pretty much similar thing here, kind of like a clean cut, here kind of rough cut. It also takes into the account for the halfway into the bolt loading into it. So now high cycle fatigue loading, still the area of the fracture or failure or the fatigue during the cycle into it, it's kind of similar into it. But now I want to apply kind of or get the accurate results into it. Then the residual stresses are up here. So that is where the nonlinear FESafe and realistic model comes into the play, where you can kind of get the right answers rather than getting the predicted answers by using the linear model into it. So that is why FPSafe is a great tool to help you with the simulation needs for your cyclic loading or the durability or fatigue analysis. And the last piece of the puzzle for the Power Up portfolio is iSight, which can be used for the process automation. So why use iSight? So this is a real example from Baker Hughes, who do make the components into it. So they make the tooling for the oil companies. So one thing they looked into designing an expander that works for the different joint applications into it. So current design process simply takes about 2 months into the analysis. So 2 months of analysis had been required to ascertain an acceptable geometry, not the best solution available. With iSight, that was done in 2 days, and that is not me or Simulia says it, but it comes from the project engineer now, who is kind of like, moved higher up into it. So iSight took us down the path we had not foreseen and gave us the confidence to keep an open mind about design. So they had not thought about the bulge into the tool of the component, and then most effective cone geometry would have never been considered because they were not looking out of the box simulation, where iSight kind of you put in the parameters into it, and that helped you get the desired results. And as I mentioned, it's kind of a disparate simulation. So you can go into the calculator component, Abacus, MATLAB, Excel. So it does not have to be just Abacus or FPSafe or Tosca. It can be anything which you can kind of extract data from and kind of drive down into the simulation aspect into it. So you can automate simulation process flows and eventually get kind of like a stochastic or the Monte Carlo simulation into it and get the best available solution, which you may have avoided, as into the previous slide, that can be kind of taken out of the simulation or taken out of the equation that can be achieved with iSight. Same thing with Tosca. You may not have thought into getting the ribs into the analysis. So this was more of like, giving you an overview. Abacus, iSight, Tosca, and FPSafe. And now I'm just going to give you a feeling of how Abacus looks, or I'm going to be running a live demo into the Abacus with our good old friend cantilever beam. So we all know the outcome of it. So the deflection is basically WL cubed over 3EI or PL cubed over 3EI. So we can go ahead and kind of correlate that with the simulation, which I'm not going to do into given the time. So I'm going to be first creating a model. So I'm going to be renaming this model as a beam model. So I'm working on a beam. So I don't have anything. This is a blank slate. So Abacus works great into the module aspect. So I'll create a part and I'll walk you through each of the analysis. So what I want to create is the 3D deformable solid extrusion component. So I'll just go ahead and create kind of a square beam into the analysis. So now I just have a 2D profile and I want to put the length of 100. So here is my part which I created for my analysis. So now part does need a material. So I'm going to go create a steel material into the analysis, and I can give all sorts of material properties, but right now I'm going to keep it very simple and give only the Young's modulus and Poisson's ratio into it. So I created a material named steel with elastic property. So then now that material has to be rolled into the section of the part, which is solid part into it. And you may be doing some FEA, so you must be familiar with the aspect of it. So now this particular part is my beam part, and I'm going to be giving solid section to that. So I'm done with part and property module. So now I'm going to be Abacus. The way it works out, you have to have an assembly to work with it. So now I'm going to go create a static step into the simulation. So this is where we go ahead and say, like, I want the standard or explicit. So I want to run the dynamic explicit simulation, or I want to just simply run the static general. So in this case, I'm going to be running just the static simulation. I'm going to be running linear static, and then simply create a step into it. So I created a step. There is no interaction applying here because I have only one component. So I'm skipping through that part, and I'm going to be creating a pressure loading onto the top face. So I'll just go ahead and pick the top face and create a pressure loading into it. So now pressure is applied normal to the face, and I need to pin the component into it. So I'll just go ahead and create the initial boundary condition, and then pick a region, which would be this guy. And then I want to go ahead and pin it, or I can fix it that as well, but being solid, pin and fix pretty much does the same thing. And now I'm going to go create a mesh into the component. So I do have a beam in here, so I'll just go ahead and assign what size of element do I need. And then simply I'll go ahead and assign the element types into it, and then create a mesh. So you can see how simple it is, and then when more parts or more components into it, it becomes a little bit kind of accurate and a little bit more kind of like, time consuming, but that's all. That is what we want to achieve into it. And now simply I'm going to go create a job, because I created a part, assigned the property, material property, loads, boundary conditions, created an assembly. Now I'm simply going to go ahead and create the job and how I want to run. So this is where the scalability comes into play. So let's say if I had about 16 CPUs on my laptop or desktop, then I can go ahead and use the scalability into it. So now I can simply go ahead and submit the job, and then also post-process the results, or also look into it. So now my FEA simulation is being run into it, and I'm done with it. So you can see that. So I submitted, I completed the results, and that is where my deflection is kind of coming into the analysis. So as you can see, I went into all module and visualization. So when I started the Abaqus CAE, or when I fired it up, I had nothing into it. But now I have the whole simulation. So that is what I wanted to show you with Abaqus CAE, or the complete Abaqus environment demo into it. And this is where my talking ends. And if you have any questions, let's open it up for the questions. And I hope this was useful, at least just to take into account for the Abaqus and Power of Portfolio capabilities into it.
Well, Dipesh, nice job. Thank you.
Thank you.
We do have a couple questions, so it seems we have a pretty intelligent audience as well. One of the questions is concerning Autodesk Inventor. Does Abaqus work with Autodesk Inventor or other CAD solutions?
So Inventor, so the way I know means like, if you have an Inventor, there is no associative interface. There is ProE, Creo, SolidWorks, then there is CATIA. So those all can be Unigraphics. So those are all can be kind of brought into it. But the way, let me just open up. So these are the files which we can be brought into the So all this are the extensions. So you can do SAT, IGS, then STEP, then CATIA, Parasolid, ProE, which was the manual associative interface. Then these are from the Abaqus simulation. So Inventor, there is, I think, I don't know what is the extension, but that cannot be brought into it unless you write into the STEP or the IGS format. There is no associative interface available for Inventor.
All right. Next question states,
Okay.
you've mentioned explicit and standard analysis. What is the difference between the two, an explicit and standard analysis?
So within explicit, it's kind of like explicit time integration where Abacus does not go into the equilibrium iteration scheme into it. It does kind of like, solve into the previous step. So it does use the explicit time integration, whereas with the standard, it does use the implicit time integration where it solves for the particular increment interval, and then once we get the equilibrium for the force, moments, and the displacement, and then we move on to the next step, and then eventually get to the total loading applied into the analysis, and that's where. So most of the structural simulation you will be doing as a implicit, but whenever you have like high-speed dynamics into it, that's when you'll use the explicit, because it will take a whole lot of time, intervals, and integrations or iterations which you don't want to deal with. So that's the major difference.
Good deal. One of our customers has written they're using Simulate, Creo Simulate, or Mechanica for analysis. What are some applications that Abacus can do where Creo Simulate leaves off? What can Abacus do more than Creo Simulate?
So what can Abacus do more? So one comes into play is the explicit. I know Mechanica so cannot be doing so. Explicit, all sorts of this simulation where you have high-speed dice impact, anything of the impact or blast simulation. That's one thing. Mechanica, the contact is not as accurate. And then the third one is the multiphysics, where if you have like, structural and fluid integration into it, or if you have like, Eulerian or Lagrangian aspect into it, that's when Abacus can do or take it to the next level.
Excellent. And one last question that we have here. So if you have any more questions, feel free to fill those in to ask us. But what are some other applications and examples where EyeSight is used?
Oh, EyeSight used pretty much everywhere, and I can basically, let me see if I have a great example into it. But anywhere you can go into the design exploration, process automation, if you want to do the kind of like a stochastic study into it, or parametric study into it, EyeSight can be used in anywhere, or it can even like, just do the, like let's say you are looking only for the stress component. In that stress, you always go ahead and do the additional operation to find out kind of like, let's say summation of S11, S33. So that can be used into the calculator component and eventually get you the best solution. And then you can take it into the next simulation where you can do the design exploration using Monte Carlo or the experiments or DOEs that can be used EyeSight as well. So EyeSight also can automate the process. So let's say if you have some workflow where you go ahead and create the mesh, and then you go ahead and submit the job on the cluster, and then eventually get out the results and look at the only one point into your output results. So those all can be automated, and you can kind of like, reduce a whole lot of time and error by using EyeSight.
Excellent. Well, Dipesh, I think that's it for our questions. So you did a very nice job today.
Thank you, Rob, and I hope it was useful. That's all purposes.
Very useful, very helpful. So you did a great job, like I knew you would. So anyway, that's going to be it for our webinar today. If you have any more questions or any information or need any additional information, feel free to contact us at info@3dsman.com. That's info@3dsman.com. So for Depesh and myself, my name is Robert Romanowski. I want to thank everybody for being with us today, and enjoy the rest of your day, and happy Thursday. Take care, everyone.